Hello everyone, my name is Filip and I will be today presenting our updates on SpaceTEEs and how they can actually be combined nicely with L2s and nicely look into the aspects actually of the new frontier of confidential computing that we are envisioning for the future when it comes to the usage of Spacecoin and the interaction with the L2s themselves. So briefly look into the agenda, so starting a bit of a motivation, actually why are we currently building Spacecoin as it is. Then dive into the aspects of the infrastructure, just provide a brief overview of our two-tier architecture because I assume that not all of you are familiar with the project itself, even though from the discussions we had before it might be actually the case, so bear with me. Then we will be also diving into the aspects of the smart contracts capabilities and try to outline some of the challenges we see when it comes to the current L2 deployments, and then dive into the parts actually on how the resilience provided by Spacecoin itself can provide additional value proposition to the L2s themselves and motivate some integration together with our infrastructure. So a bit of a motivation, just like why are we actually looking into the Spacecoin as of now. And the main aspect that we definitely see, and it's an open problem when it comes to on-Earth deployments, is that it's providing reduced cooling cost. So that way when you basically launch the stuff to the space, you don't have to necessarily worry about cooling. You have to, of course, make sure that your system can operate properly up front. You also actually are getting access to the solar power itself, because of course your satellite itself has to be self-standing and have enough power. It will be coming from the solar panels on the satellite itself. We see that with the current development that we'll be actually able to achieve lower latencies when it comes to the applications that actually are relevant for us, assuming that the infrastructure itself will be developing as we envision. And definitely we see the aspects of providing a large-scale communication network actually people can interact when. I believe many of you are following the aspects of Starlink and others, where many actually other countries or companies are trying to provide such type of infrastructure, which is resulting in the part, as we see on the right side, as a fun fact that we are actually observing much more launches with much more satellites that have been launched in the past 2 years than in the past decades, pretty much. So providing also a bit of an overview what is actually Spacecoin. So Spacecoin itself is a robust layer 1 solution that will be running in space. By itself, the individual units, the satellites themselves, are serving and providing SpaceTEE functionality. I'll be also diving on the next slides, providing a bit of an overview, how do we differ from traditional and trusted execution environments on Earth. And we, of course, aim to be smart contract platform, meaning that you can actually take and deploy your EVM smart contracts and run them on the robust L1. We envision, of course, as the capacity of the network will be increasing, that it will be made mainly for specialized purposes in the early phases, but eventually we want to make it open so people can deploy full-fledged smart contracts to available to basically anyone. And we envision several interesting use cases, starting with the future of space computer, where basically we want to provide infrastructure and marketplace for payment satellite service providers, because we see the future will be not only a single but multiple satellite service providers in the future running and operating their infrastructure in space, and we can be the layer in between them to make sure that actually they can operate and interact and settled on the L1 itself. Of course, there is much more, and since we are in the early phases, we are happy for any input because we can always try to adjust our design for a particular use case that you might have in mind and get inspiration moving forward. So what does actually Spacecoin provide itself? We just have two main groups currently. So the first one is focusing on the Earth users, which will be something we'll be actually diving more into the detail as of now, which is with providing additional security guarantees to L1s and L2s. So for those who have read our blue paper, we have more discussions on that part in it, but happy to also dive into it during the Q&A later on. For the scope of the today's talk, we'll be mainly focusing on the aspects of L2s themselves, where we envision that the L2s providers themselves are our users as well, but also the users interacting with the L2s themselves will be getting this additional security guarantees provided by us. And of course, for the RPC nodes, it will be the aspect of availability. We envision to provide them dedicated communication links where they can have, of course, the classical communication as we know it on Earth, but also can have dedicated backup links, basically, that will be able to interact with our infrastructure. Coming to the aspect of the challenges and the state of the art where we currently are at, we definitely see that the space infrastructure that we'll be building on doesn't, of course, have the easy options of launching new nodes and scaling your system when it comes to the hardware specification and the latency and so on that we foresee in the future. But with that in mind, we have to design our system that will have rather in the early phases limited transactions per second capabilities, and will, depending of course with L1 we will be comparing it, but we'll have a slightly larger finality, but instant finality, meaning that after we are running through the consensus itself, we will basically have an instant finality without going through the aspect of probabilistic nature that we see on some chains as they are. And to achieve scalability of our system, we are looking into the aspects of scaling through L2s. So basically the paradigm like we know, for example, from Ethereum or others. And we, of course, are interested in providing robust communication among the individual peers in the system itself. And a very crucial aspect, because we see that the state of the network itself as it is now among the individual satellites keeps rapidly changing. We want to make sure that our consensus will be changing along the way. So we are definitely interested in dynamicity and the possible upgrades of the system to accommodate for any type of additional latency improvements or throughput improvements that will be provided to our system to make sure that actually the system can nicely scale in the upcoming years once the underlying network will be basically improved as well. So overall, with this constraint, we are designing for this 2-tier architecture where we have the robust L1 running in space. It will be providing a celestial in orbit for security, so you can think of it like a very robust and secure L1, with the on-Earth component, which will be the layer 2 that will be providing us the scalability solution itself. And of course, we are looking into the aspects on how to bring some novelty into the picture when it comes to combining the benefits of rollups together with stage channels when it comes to the fast finality or pre-confirmations in comparison to others. In the upcoming slides, I'll be talking about 2 dimensions of the resilience we are providing. So the first one is focusing on the communication resilience. So for that, we are currently relying on the Iridium network that is actually already having a distributed network of satellites, where some of you might already know it from some use cases when it comes to emergency messaging and others that are basically providing and using Iridium as an underlying network. And this is the underlying network that is currently being used by our initial provider, which is called Aptos Orbital. Maybe you have known them from the past as CryptoSats. They ran it recently, and they will be the initial partner we are working with to provide us the infrastructure. And we are building on top of it, meaning that actually we are having our aspects of the underlying infrastructure on top of which we are building the protocol that will be able to orchestrate the interaction among the individual satellites to provide the layer 1 functionality to the others. And we, of course, are aiming for making it resistant and denial of service attack resistant for this aspect. And for that, we are looking into the various paths on how actually either our protocol or actually the underlying network that we'll be using already can provide some of these type of guarantees as well. Looking on the other side of once we have the communication in place, what actually are we interested in when it comes to the computational resilience? We are looking into the space trusted execution environments. So providing a short overview, what are actually TEs. So you can think of the current model of TEs as we know it, for example, into Intel SGX and others, that are providing an isolated region on a CPU that is providing additional instructions to the users that are building their application and the developers, of course, in the on the TEs that aims to provide a secure environment for your code and data that can be used during the runtime of the system, and are providing confidentiality and integrity to the code and the data itself that is running inside of the TE. And also, if you look into some of the modern TEs, they are providing remote attestation capabilities, meaning that you can actually prove and verify that, okay, I'm running this particular binary, and you can convince others that is actually the case itself. Providing a just short overview, so that way you roughly know how do we position ourselves when it comes to the SpaceTEE. We have 2 main families of trusted execution environments. So first one is called process-based, meaning that you actually run only a single thread of your application inside of the enclave. So for that we have, for example, Intel SGX, or most of us have it as a part of our phones inside of the pockets as a part of the ARM trust zone. Or we see the more, I would say, modern design, which is the virtual machine-based solutions, for example, like Intel TDX or AMD SCV-SMP, where you can actually deploy all your virtual machine inside of the trusted enclave itself, which of course comes with the trade-offs of increasing the trusted compute bound, or in short TCB, while of course providing additional usability to the people so you can easily migrate your code base inside of the TE. How we position ourselves when it comes to the SpaceTEE is to basically have robust software instantiation of the TE itself, which of course is much more attractive when it comes to upgradability and other type of solution, with physical isolation, of course, because our infrastructure is running in space, so it's rather challenging to get a physical access to it as of now. Let's see how it's going to change in the future, but at least as of now, this is the underlying assumptions that we are building on, and of course want to extend with this unique property the trust assumptions when it comes to building robust protocols on top of it. So for your mental model, how you can think of the SpaceTEE is like we are getting the trusted compute bound coming as a part of the VM-based solution. So from the usability perspective, it's very attractive. You can just deploy your application inside of the satellite, and you will be providing automatically with the VM-based like usability, with of course the additional advantage of having a robust physical isolation, where if you look into Intel TDX or AMD SCV, they basically are not resistant to any types of physical attacks when it comes to side channels or other type of consideration. So this is basically the interesting selling point when it comes to the SpaceTEE and Spacecoin in general. Taking this into account, we are now looking into the aspect actually of what are the challenges we have identified in current layer 2 solutions. So of course, something that we cannot necessarily help, but see actually a nice way on how to provide additional solutions in the direction is that we see that, of course, if you look into rollups in general, there can of course be a lot of type of bugs and other type of challenges for which we already see solutions, for example, like multi-prover setting, that you try to actually have not only single sort of truth, but actually try to have multi-provers that actually try to provide and compute the respective state updates as they are. We of course see that in the current deployments there is quite a lot of trust placed on the sequencers, meaning actually that the sequencers themselves are trusted, right? They are operated by usually single entity. So of course if they want to behave maliciously, they can theoretically censor, or of course they can have some availability issue, meaning if they are down during the time of their operation, it can be a problem, or they can, for example, not properly communicate with the underlying layer 1 infrastructure. And the also present aspect for the user themselves, that always we see that they have to wait for the finality of the underlying layer 1 solution as well. So of course, even though you are getting a certain user experience that when you, for example, start to sequence your transactions, you still have to actually wait to make sure that the L1 itself will finalize the transaction itself. And definitely what we also see is the aspect of interoperability, which I think is currently quite a hot topic in the ecosystem, that people try to look for ways on how to standardize the approaches to make sure that the systems are more unified. So this is basically where we come into the picture and try to bring up some interesting solutions to the table that are actually combining the aspects I was mentioning before when it comes to the computation and the communication resilience as it is. So the first direction is focusing on defense in depth. So of course we want to provide already to current established system as they are additional aspects of multi-prover, meaning that you can actually already use your current system as they are with additional extension to running your multi-prover setting in the traditional trusted execution environments on Earth, with additional component of running inside of the SpaceTEE, where of course this will be providing additional aspect of security to your system, but also consideration of decentralization, where you can have multiple of these provers that are providing additional security to the users of the system themselves. And the second part is more on the aspects of the users themselves when it comes to additional security guarantees, but also providing, I would say, general robustness to the L2 architectures themselves, is the focus on the pre-confirmation, where I was mentioning we are basically waiting for the finality of the L1. So here we basically try to get additional improvement to the state of the art. I will be talking about it more in the next slide, on getting additional types of pre-confirmation for the L2s, and also provide a dedicated form of communication channels between the sequencers to the satellite and later on to the L1 that can provide some additional security guarantees when it comes to non-availability, when it comes to the communication between the sequencer and the L1. And of course, in general, try to provide some form of standardization that our solution shouldn't be applicable only to some L2s, but we are looking for the ways on actually how to make it applicable to various types of L2s as well. So this should kind of be helpful for many partners we plan to engage in the future for our scalability solution. Talking a bit more about the pre-confirmation for L2s, so you can think of it that when the user is basically interacting on Earth with their respective L2, we want to provide a general additional attestation proof before it gets settled on the L1 by basically generating and running the state updates inside of the SpaceTEE itself and provide attestation where actually the satellite that will be available at a given point in time will be able to compute these updates and provide this attestation proof basically to the user itself that will get additional confidence that the update that they are talking about is possible. But of course the advantage is that you don't have to wait for the whole consensus to finish, just basically you will be getting these initial guarantees by running it on the respective satellite itself. So this is the general gist of the pre-confirmation. I'm happy to discuss more about it in the upcoming minutes as well. So overall, we definitely see that, of course, we are interested in the scalability of the solution that for Spacecoin itself to function properly, but see an interesting value proposition when it comes to the mixture of the computation and communication resilience we are offering. And we are planning to actually have quite a lot of L2s integrated into our system, but are in the initial phases due to the capacity of the network, looking into selected partnerships with various L2s. And are continuing our efforts moving forward when it comes to the proof of concept, which brings me basically to the overall plan that currently we are in the phase of finalizing our white paper, which would provide the specs of the protocol itself, of the L1. We are also looking into the aspects of integrating first L2s on board, meaning actually they will be able to deploy their bridge smart contracts on our L1. And of course, along the way, keep extending the capabilities that I didn't have time to touch on during today, but definitely we see a lot of interesting applications when it comes to custodial wallets or randomness that are basically provided by the satellites themselves. So in general, we are also, of course, looking for partnerships when it comes to L1, L2 foundations, wallet providers, validators, entropy providers that will be happy to interact and get in touch with. So if you are interested, get space built. We'll be around for the whole week engaging. We'll be also participating in the hackathon, so we hope to build quite a new use case when it comes to the interaction with the satellite, and happy to get in touch. Thank you very much. And we should have some time for questions. Yes?
VMs. What VMs? Only EVM?
Currently we are aiming at EVM, but in the future hope to extend it by other type of VMs as well. We are quite actively looking into also RISC-Vs and others, but for now we are mainly aiming at EVM.
Yeah, what types of use cases do you envision where users might opt to pay for block space or SpaceTEE? What are the products you envision users taking advantage of these exclusive guarantees that only you can provide?
I think as we have seen, like for example, with certain types of attacks, if you're like transferring a large value of funds, I think this actually will be beneficial for you to consider getting this additional security in place basically that we can provide. So I think definitely the high value transactions will be something that we are aiming for, especially in the early phases, because the network just cannot simply scale for any type of smaller transactions. But definitely this is something that we are envisioning. But I think the stuff I don't have, for example, time to dive into when it comes to use cases, we also plan to collaborate with various L1s as well, and providing them, for example, additional checkpointing capabilities themselves, so that part you don't have to only rely on the transactions of users, but are looking for the ways on actually how to provide updates and checkpoints for the whole L1s, and basically have this root of trust coming from the Spacecoin L1 itself. So these are, I would say, the high cost, high loss basically type of use cases that we are currently envisioning. Yes?
How can we verify that the node software running in space is or matches what's on the GitHub page?
Yeah, I mean, this is like not only applicable to us, but to any type of TE, right? When it comes to, for example, the VM-based solutions. And we'll be, of course, looking for the aspects of reproducible builds. So there's, I think, currently quite a good pipeline of tools that you can basically make sure that you are using to make sure that your binary that you are able to check out, from our repo or from the study that will be running on our satellite corresponds to basically one-to-one that you are observing. Yeah.
What are the capital costs you estimate to launch one proof of concept satellite and then an entire constellation of satellites to support this network?
Good question. I think the costs vary quite largely. So I mean, fortunately, what we see the general trend is like the cost per kilogram is going down. So we are somewhere in the order of a couple of thousands of euros per kilogram. So let's say if you want to launch our own CubeSat, we are talking somewhere around maybe 40K for the launching cost. Can be also cheaper depending on how powerful is the satellite. And we definitely envision that we will either have a full like our own satellites or also actually plan to look into and tap into the aspects of satellites that are already either in space or will be launched that have actually enough spare computational capacity and are not being used all the time. So with that, basically the range varies somewhere between tens of thousands of euros until millions if you want to have like your own geo satellite based unit that basically is only unique for you.
It's commodity hardware that exists today that is rad hardened and can be deployed.
Correct. Yeah, it exists nowadays. Yeah.
Execution environments.
Exactly. You can think of it as basically some student projects are already launching currently CubeSats that basically are able to provide certain type of capabilities. Usually, of course, they disappear after a couple of weeks in the sense like they are not really made for the longevity, but rather as a proof of concept. So on that part, you already have, I would say, cheaper solutions as of now. But if you want to have something that will be able to run for 5 to 10 years, of course, you have to put additional effort into the design of such units to make sure they'll be more radiation resistant. But there start to be more and more solutions in this direction.
One more is, what are the compute requirements for a platform like this? Because obviously these CubeSats, these student ones are megahertz,
Yeah.
100
I mean,
megahertz.
the current specs we are aiming for the computational powers, you can think of it like a Raspberry Pi, basically Raspberry Pi 5, which I think is, of course, not as a powerful machine as when it comes to running very beefy, BFT node. But I think if you look at the requirements for Ethereum validator, it's actually something that is totally sufficient to make sure it's functioning and can work quite in a reasonable fashion. So I think this is the scale. But of course, it's become the trade-off of computational power that comes also with it additional heat generation. And then you basically have to also consider how large your cooling has to be to basically make the stuff functioning for the long period of time. And then of course, the more power draining, the more power you need to operate your unit, the larger the satellite itself has to be in order to have enough power from the solar systems, basically, to make sure it's actually functioning. So it's like quite interesting mixture of trade-offs you have to look into.
Are you exploring like other novel interesting things you can do because you have space, like ETHDenver?
Yeah, we are looking into that. So some stuff that I didn't mention today in detail, but we, for example, provide the randomness. So we have like 2 random number generator. Basically, it is coming from the satellite and it's collecting the entropy from the radiation in space. We are actually now working on a demo that should be available in the next couple of weeks, where you actually can interact with the satellites to get the randomness and basically use it as a part of your protocol. So we hope to have some fun hack in the upcoming days that will be already relying on this type of solution. Yeah, but of course we envision to have also aspects not only of the randomness, that I think it's a cool feature, but it should not be the main work that we want to provide, but it's a stepping stone basically to make sure that stuff are working and for us also get familiar with all of the aspects of the environment we are working in and keep building on top of it. So definitely some stuff that already a single unit can provide is, for example, a solution for custodial wallets, where you can either have your partial key share stored on the satellite and keep using it in combinations at 2 out of 2 MPC, where you have one share there and one maybe on your laptop as well. So this will be some of the future use cases we envision moving rather fast. Yeah.
Yeah, but QKD would be an interesting use case indeed.
Yeah.
And the wallet use case you've talked about with TEE, so
Yeah.
So you do envision your TEE as a service, for example.
Yeah.
I still can use your TEE to split my signer key, for example, for the wallet.
Yes, exactly.
And keep the signer on your trust environment.
Exactly. That will be, I think, the stuff we envision. Yeah.
And how do you? So you're currently on EVM chains, yeah?
Mm-hmm. That will be the plan. Yeah.
So
I mean, disclaimer: we are not on. We don't have a full-fledged, like a testnet or something. But it will be the plan.
Let's talk about the
Yeah.
future.
Yeah, exactly. Yeah.
So that means that if I deploy my EV signer for smart wallet, for
Yeah.
example, on your TE, that means that I will be able to call the signer to sign to sign the transaction on behalf of the user smart wallet
Yeah.
on all EVM compatible chains.
That will be the plan. Yeah.
So it will be Ethereum, it will be optimistic rollups.
Yeah.
I assume.
Yeah.
What about ZK rollups
Should be as well. Yeah.
as well?
Yeah. So basically, any type of L2 that can deploy their respective bridge smart contract, we should be able to interact with, of course, in both directions.
Okay, and how do you will address this cross-chain thing? Because you are a separate L1.
Mm-hmm.
You are planning to use some kind of messaging protocol to.
That will be something we're investigating. Currently, we plan to just use classical bridging solutions to either bridge to the L2s on Earth or basically bridge with the L1 directly. But we will be looking into, I would say, more robust ways in the future. But for now, basically, we are looking into the classical bridging solution, most likely between the L2s on Earth themselves. Yeah.
Okay.
Mm-hmm. Yeah.
How are you going to have reliable internet connection?
Yeah.
By Starlink or?
So future it will be Starlink, of course, or some other similar like provider. But as of now, as I was mentioning, we are relying on Iridium. So basically, as long as you have an Iridium terminal, you'll be able to interact with the satellite itself. Because Iridium itself is already providing a large, I would say, quite robust network of relay stations on Earth, to which basically you can send the information to that will be talking to the respective satellite on your behalf. So maybe I can go quickly to the picture. No, all good. It's a good question. Yeah, so you can think of it like this. So basically, you will have your Earth component, right? That basically will be able to tap in and talk to the Iridium. Then you have the underlying Iridium network and then you have our satellites that are talking to the Iridium. And then we basically have the protocol running on top of the respective nodes. Yeah. So as long as you have accessibility to Iridium, you should have an accessibility to our peers. Yeah. There will be, of course, like some form of. I didn't dive into it today, but if you're interested, of course, there comes certain type of challenges because Iridium itself is available all the time. But as you can imagine, we will not have a large constellation in the early phase, so only a subset of the satellites will be able to communicate to the Iridium in the initial phases. So it's basically something we have to accommodate for in the initial design when it comes to that before the constellation of the satellites becomes larger to communicate via the Iridium. But ideally, you should be able to, in the future, replace Iridium by any type of other provider, either Starlink or other type of solutions that will be available.
So why do you need Starlink if you're going to, let's say, if you're going to just use Iridium for now?
Throughput. Basically, I think this is the latency and throughput because Iridium itself is
Starlink relay is more efficient.
exactly. Yeah.
Yeah, because Iridium has ping issues.
Yeah.
I remember having a Iridium cell phone.
Yeah. Exactly. It's basically like latency because Iridium doesn't have as many satellites as Starlink, right? So basically, because of that, they just don't have so much coverage and so much throughput and latency as Starlink would have.
How do you coordinate the kind of intra-satellite communications? You're dealing with, it sounds like you're dealing with finite amounts of bandwidth between these satellites.
Yes.
So how do you prevent congestion and spam? Like, is this constrained by the block space of the blockchain?
Yes, exactly. So we're gonna have to design for this constraint space, basically.
So the physical hardware requirements, it's the same with any blockchain.
Yes, exactly.
The limitations.
Exactly. This is kind of what we are, that our protocol, that's the reason why we are a little bit behind the schedule when it comes to speccing out the protocol, because it's very dependent on all of the combinations of the underlying Iridium network, of also the intra-satellite communication via Iridium network, and many others. So it's basically something that we have to accommodate for, not of course for the current state, but also have a good solution that will be, we don't have to change in 2 years in case suddenly Starlink communication for intra-satellite communication become easy. So we are looking for basically future-proof solution as well that will allow us to easily scale throughput and other aspects as long as we have better connectivity for between the underlying network. But ideally, we also want to have like heterogeneous networks, right? We don't want to have only a single provider, so that way we have a different type of fallback solutions in case one of the provider chooses to not provide a service or whatever, but they basically have more robustness and resilience in this type of directions. Exactly, exactly. So kind of learning from the mistakes that we see on Earth, and try to build up for a better system when it comes to the space computer solution. Yeah.
Would it be like long-term, long-range potential like attack vectors or like surface areas for weakness or failure in the space-based system? Like just an example, you can imagine like this X project,
Yeah.
this Space Force project, where they can launch a reusable shuttle to capture satellites.
Yeah.
That could be.
That could be a problem, of course. For that, that's the reason why we also are not only relying on a single satellite, but are running a whole BFT consensus among all of the peers, right? So ideally, if one of them is compromised, then still the others should be able to operate. And then, of course, it's just a matter of operating the sensitive operation also in such type of a fashion. So the more computation we will have, then of course we can look into solutions like MPC or other parts that will also basically make sure that even though we have the SpaceTEE provided by each of the individual satellites, we have like a defense in-depth approach also as a part of the protocols we are building on top of it. So that way we really try to make sure there is like no single point of failure in the whole system as we are building it moving forward. Yeah, that will basically is the plan.
I have a minor question on the topic. Why did you choose ETHDenver in the first place? Since you're saying that
Yeah.
Starlink has more.
Good question. I keep asking myself. It's not that we don't. We want to go with Starlink.
The Iridium, it's like a meme from early.
Yeah.
From early 90s.
Exactly. Yeah. It's like it's a good question. The reason for that.
That's why I remember the Iridium cell phone with a huge antenna module.
It's like and like piling it up to get enough power to send a single message, right? Like no.
Yeah. And I also remember that you should keep your antenna in a 90-degree angle because it will not saturate.
Iridium advantage over Starlink at the moment, and it will change, but at the moment is that they can provide third-party inter-satellite links, where Starlink didn't open it as a vendor.
So it means like if you use Iridium network, you can still use Iridium as a relay.
Correct.
Satellite.
Correct. Basically for the
Currently with Starlink, you cannot think about consensus.
Yeah. Basically,
by consensus, you mean you're using Iridium, but Iridium, let's say Iridium is a layer 1, and Iridium has other providers that aggregate.
Yeah. So basically, what you are not getting what is missing by Starlink is, of course, Starlink is great in this first Earth to Starlink, right? This is their main use case. They want to provide usability to users on Earth, but they don't have like antennas facing to the satellites that will be running above Starlink itself. So basically, they cannot really provide this type of functionality, whereas Iridium has this already built in, and you can basically subscribe and have communication from your satellite via the Iridium network communicating to Earth. Starlink currently doesn't have it, or it's not open.
Yeah, like we don't know what exactly they have, but they're not selling it for other
So sounds like that for now, Starlink is a closed ecosystem for the real.
I think on that part you can call it like that, or they just don't see currently the demand of having too many people that will be running their own satellite and communicating via Starlink to communicate on Earth, because there are already some other solutions. So they maybe focus and put effort on the Earth users that will have a regular subscription, and in the future want to open it to the other satellites that will be able to communicate via Starlink. Yeah. So I think it's not like it's technologically not possible.
Okay, so the right thing to think about is Starlink is like a different layer 1, not even compatible.
In some way, you can think more like I would say, different type of provider, like communication provider, right? That basically is asking you to use a dedicated antenna, like dedicated, like not Wi-Fi 6 standard as we see everywhere, but basically, okay, you only have to use Starlink, and they're currently not opening it to anyone to join. So more like in this direction. So it's rather, I would say, call it like a difference between Bluetooth and Wi-Fi, rather in that.
And also, I remember you mentioned RPCs.
Yeah.
So I assume it's still on your roadmap. You don't have RPCs yet.
Yep.
But what's your benchmarks and estimations performance-wise? So because I assume that now, given all that you just said about the coverage of Iridium and the ping issues, at the start, satellite RPCs will lose performance.
Sure. I mean,
They will be less performant.
Yeah. So it's more like that. I agree. The aspect that for sure, like, you cannot compare it as of now to.
What would be the advantages of?
The advantage will be that your RPC will be able to communicate via additional communication channel, it will be in this case Iridium, to get additional security guarantees. Basically, that is, like, I would say, the main advantage. So not necessarily focusing on speed and high throughput, but rather guarantees that will be provided to you by the mixture of the different type of communication medium you will be using together with the SpaceTEE guarantees. So focusing on the resilience, basically, of these two individual solutions. Yeah. That, I think, is the way how we can think about it.
So you can use like an emergency provider.
Correct. Yeah. Exactly. Yeah.
Okay. And just in case, do you have an estimations on how satellite RPC is slower compared to Earth-based RPCs?
Slower in the aspects of latency, or in which?
Latency, yeah.
Yeah, I think we are talking instead of on Earth, it's usually milliseconds, right? I think here, at least when it comes to usage of Iridium, when we want to run our own RPC node, we are talking about order of seconds. Yeah, it's basically roughly to get a feeling.
Sorry, what is Aptos Orbital? Is that a...
So they are our initial infrastructure provider partner. So they are basically the one that is, because we don't aim to have in the initial phase our own design department will be building the hardware. So basically, we are looking for various infrastructure providers that can provide us the satellite functionality.
They don't really have a network of satellites.
They have, I think, currently some satellites. Yeah, not a network.
The satellite we have access to is the
Exactly. Yeah. They don't have a constellation, so they have some satellites. So
Are they like a traditional satellite communications company?
correct. Yeah.
Okay.
Yeah. So they basically provide the infra aspect. Mm-hmm.
Maybe you covered this during your presentation, but is there a reason, like, why is the orbit of Spacecoin far beyond like crypto?
I think it's more like the illustration to kind of see how is it layered. But actually, you can think of it basically that the Spacecoin itself is running on the crypto satellite themselves. So it's just like more like kind of to see the individual layer that kind of we try to identify the individual parties, So we have the Earth, of course. Then we have the communication provider, Iridium or Starlink or whatever. You can replace it by whatever you have. Then you have the infrastructure provider, that is like the satellites where the actual nodes will be running. Ideally, of course, we want to have different type of providers as well. So that way you can have like one provider could be them, then you can have a mixture of CubeSats, whatever stuff, to make it permissionless, so people can launch their own stuff. And then, as long as you can deploy our binary, you should be able to communicate among the individual peers. That's basically kind of like the layering approach. So it doesn't mean that actually it's physical farther from each other, but it's just like more like
actually more like
the layered.
Iridium is the
Yeah,
stationary and
exactly. Yeah.
Yeah, you mentioned like this Spacecoin satellites are going to be far above Starlinks. Right?
Yeah.
So
Could be in either direction, most likely. Yeah.
Yeah, to connect to Starlink, then I guess you have to be the same or below that.
Yeah, exactly.
It's mostly like 300 kilometers. I don't know if it's in miles, but
Yeah.
Yeah, I understand kilometers.
Yeah.
then most of low Earth orbit would be at 500 kilometers.
Yeah.
So, just pushing this out even further,
Mhm.
these wood experiments, what does interplanetary consensus look like?
Yeah.
You're dealing with these very large kind of speed of light limitations.
So I think that the aspect, of course, will be in the future that you can maybe have your RPC node, like you can have the whole constellation around the Earth as of now. In the future, you can start to think of it like you will have like dedicated bridge to the next constellation on Mars, right, and Moon, and going like very, very wild. And basically, they'll be able to communicate with each other with, of course, very, very high latency, but they will have a form of communication.
Small block time.
Exactly.
But look, you have dispute period of 7 days today between on Earth. So if we can do like a few days on
I think it can be faster.
Do you envision this being like sets of disjointed networks which have like these bridges between them? So Earth will have its own.
Good question. I think
consensus?
ideally we would like to make it as a one particular communication, but of course then we would have to see if they are just like participating in the consensus because of the delay or the bridging. I think it will be more like a disjoint networks. I think will be more reasonable approach, so we are not being slowing down by the latest latency.
Independently building their own set of blocks and they're just synchronizing state.
Yeah, exactly.
ZK or
Yeah, exactly. I think that would be the vision. Once we start, we also have like enough powerful hardware to actually do real-time ZKs, in space and so on. I think.
And after that, imagine how EMV
Yeah.
So they can front run nodes that are on Mars and
Yeah.
on
First
Earth.
come, first serves, you know? It's like next level.
For Miller to start thinking about the next flashbot
Yeah.
architecture.
But at least in the early phases, like just being on the Earth orbit at the beginning, get that one right and then start to scale. I think there is already quite a lot of interesting applications that actually, when we are discussing with people, they are looking into the direction of not always having to rely on orchestration from Earth, but will be happy to just take in the communication among the individual objects they have in space and get orchestration from them. So it's basically something that we want to provide.
Could this be used to build like proof of location, clearly?
Yes.
You build
That's basically what we are looking into. One aspect is proof of location, of course. Other aspects is VDFs, right, as well. So I think there could be quite a few interesting use cases you can keep expanding in this direction, provided by
What is proof of location by the way?
that you can think of it that because of course the satellites are running on deterministic orbit, right, as they are. You can basically, if you are able to communicate with them from Earth to them, you can basically see, okay, I'm in this particular area of the physical location on Earth because I'm able to reach the particular satellite in space. And you can get like a validation or attestation basically from the satellite itself that this is the actual case. There is quite a nice paper in this direction that I'm currently, this is something that we are currently looking into to provide for such type of applications.
Just speculating. What happens if I spoof my coordinates?
Mm-hmm.
So I fail to reach the spoof location consensus
Yeah.
if I spoof the coordinates. So let's say we're here in Denver, but I spoof my coordinates and
You can try to.
And I say to the satellite.
It's the other way around. The satellite itself is providing you the attestation that you are in here. So even if you try to spoof it, the satellite doesn't care. It's basically the satellite is the source of truth, not your spoofing. So it's more like the satellite is providing the proof that okay, you're actually in this particular location.
The GPS module of my device is here.
It's not necessarily about the GPS aspect itself. It's more like from the aspect that you can reach out to them based on, for example, the latency. You can calculate that you are in this particular area.
Oh, yeah, that's true.
It's more like the other way around.
Because if you spoof coordinates, the latency will still
Yeah.
your real location.
Yeah.
GPS are typically spoofed from the satellite, not the other way.
Yeah.
What you'd want is like you would be sharing, or the network would be sharing signed timestamps.
Exactly.
And then using your knowledge of the constellation network, you would be able to you would generate a proof of your location, and then other verifiers would recompute your GPS. So the stuff that's happening on edge, on the chip, would just be computed by the verifiers.
Yeah, it makes sense.
Great. It was a very enjoyable discussion. Thanks a lot. I didn't expect it, so it was great. Thanks a lot for all the cool ideas and the cool questions. And happy to catch up more. Thank you very much.